Chapter 10.3 Composite Functions. Composite functions are functions formed from two functions, like f of x and g of x, where one function is composed of the other function. We can write this as f bracket g of x, or f and then little open circle g of x, and we say these as f of g of x. So remember, when we write multiplication of functions, we can write f times g of x, but for composition of functions, the little dot is an open circle. So make sure you understand the difference between those two and can identify when it's multiplication and when it's composition. So in f of g of x, function f is considered to be our outer function, while function g is the inner function, and function f depends on function g. Always do the inner function first, then substitute what's in the brackets for the x in the outer function. So in f of g of x, normally we have g of x or f of x, and we take an x value and plug it into the function g and see what we get. But when it's f of g of x, we plug the x value into g of x, then we calculate what g of x equals, and then that value becomes the input for the function f. So we put the value of g of x in where we would put x in the function f. Note, f of g of x is not the same as g of f of x, so the order matters, just like subtraction and division. Composition f of g of x is not the same as multiplication, so as I said up there, make sure you can identify the difference between the open dot, which means composition, and the solid dot, which means multiplication. Writing composite functions, the composition f of g of x has the following rules. Substitute the formula for g of x into f of g of x. Then write out the formula for f of x, and wherever there's an x, substitute the formula of g of x, and then simplify the equation. Let's practice. Determine the equation of each composition if f of x is 2x plus 1 and g of x equals 3x. So f of g of x, which means f of g of x. So we want to plug in the g of x into the function f. So f of what is g of x? It is 3x. Then what is f of x? It's 2x, which in this case, we're plugging in g of x for x. So 3x plus 1. So we took the function g of x and we plugged it into f of x wherever we saw an x. So now f of g of x becomes 2 times g of x, which is 3x, plus 1. And then we want to simplify this, so we can multiply 2 times 3 is 6x plus 1. So f of g of x is 6x plus 1. Next, let's do g of f of x. This means g bracket f of x. So we're going to sub in f of x into g anytime there's an x. F of x is 2x plus 1, so we're doing g of 2x plus 1. G is 3x, so 3 times the f of x in this case, 2x plus 1. So we're taking f of x and we're subbing it into g of x every time there's an x, which is after the 3. So 3 times 2x plus 1. Then we simplify. 3 times 2 is 6. X, 3 times 1 is 3. This is g of f of x. Does f of g of x equal g of f of x? We had 6x plus 1 and 6x plus 3, so no, they are not equal. The order matters here. Determine the equation of each composition if f of x equals x squared minus 4 and g of x equals x plus 1. F of g of x is f of, what is g of x? It's x plus 1. So that's saying in the function f of x, plug in x plus 1 anytime you see an x. Our function f of x is x squared minus 4. So x squared, instead of writing x, I'm going to write the function g of x, which is x plus 1, and then that's squared, and then minus 4. Then we can simplify, so we want to multiply out the binomial, x plus 1 times x plus 1, and then minus 4. X times x is x squared. X times 1 is 1x. 1 times x is 1x, so that gives us 2x. 1 times 1 is 1, and then minus 4. We get x squared plus 2x minus 3 is our f of g of x. F of x, just saying take the function f, and inside of it, wherever there's an x, plug in the function f of x. So f of x is x squared minus 4, and again, f of x is x squared minus 4. So wherever we see an x, which is the first term, x squared, we're going to plug in f of x, which is x squared minus 4, then squared, then minus 4. Multiply the binomial, x squared minus 4 times x squared minus 4, and then minus 4. X squared times x squared is x to the power of 4. X squared times negative 4 is negative 4x squared. Negative 4 times x squared is negative 4x squared. And negative 4 times negative 4 plus 16, and then minus 4. Which simplifies to x to the power of 4 minus 8x squared plus 12. 16 minus 4 is 12. And that is f of x. F of x equals negative 3x plus 5. G of x equals x squared minus 2. H of x equals 2x. Find f of g of h of x. F of g of h of x can be written f of g of h of x, close all those brackets, which equals f of g of, what is h of x? It is 2x. And then we can plug 2x into the function g of x anywhere there's an x. So we have f of g of x is x squared minus 2. So now we would be doing 2x squared minus 2. We can simplify that. We get f of 4x squared minus 2. And then we can sub what's inside the brackets into our function f anywhere there's an x. So we get f of x is negative 3x plus 5, so negative 3 times 4x squared minus 2 plus 5. Multiply the negative 3 into the brackets. We get negative 12x squared plus 6, and then plus 5. And combine like terms, we get negative 12x squared plus 11. F of g of h of x equals negative 12x squared plus 11. Given f of x equals x minus 3 and g of x equals the square root of x, determine the following and state any restrictions. First, f of g of x, which we can write as f bracket g of x. So then it's f of what is g of x? G of x is square root of x. And then f of x is x minus 3. So where we have an x in f of x, we plug in g of x, which is square root of x, which gives us square root of x minus 3, which is our f of g of x. And restrictions here, we have a variable under a square root. That variable has to be greater than or equal to 0. So with x greater than or equal to 0. G of f of x we can write as g bracket f of x, which becomes g of what is f of x? It's x minus 3. Then we sub x minus 3 into g of x where there's an x. G of x is square root of x, so we get square root of x minus 3 is g of f of x. And we have x minus 3 under the square root, which means x minus 3 has to be greater than or equal to 0. If we add 3 to both sides, we get x has to be greater than or equal to 3. So our restrictions is x has to be greater than or equal to 3. If f equals the points 3, 5, negative 1, 4, 1, 6, and g equals the points 6, 3, 2, negative 1, negative 2, 1, determine the following. F of g of x, which we can write as f bracket g of x. So we always look at the inside function first. So I want to look at g of x. I'm going to make a table of values with my points. I have x and then g of x. So first point is 6, 3, and then 2, negative 1, and then negative 2, positive 1. Then I'm going to write my f function, x, and f of x. So if I put in a 6 into g of x, I get out a 3. If I put that 3 into f of x for x, what do I get out? Looking at f of x, I get the point 3, 5. So if I put in a 3, I get out a 5. This tells me that f of g of, what number did we put into g to get the 5 out of x? We put in a 6, and we got out a 5 from f of x. So f of g of 6 equals 5. Next point, 2, negative 1. If I put a 2 into g of x, I get out a negative 1. If I put that negative 1 into f of x for x, what do I get? We have negative 1, 4. So I'm going to get out a 4 when I put a negative 1 into f of x. Then f of g of, what did we put in originally? We put in a 2 at the very beginning. At the very end, we got out a 4. So f of g of 2 equals 4. Last point, if we put negative 2 into g of x, we get a 1. If we put 1 into f of x, what do we get out? 1, 6 is a point in f, so we get 6 out of f of x when we put a 1 in. This tells us that f of g of, what was the original input? Was negative 2 that we put into g of x. And what did we get out of f of x? We got a 6. So f of g of negative 2 equals 6. Now g of f of x, We can write this as g bracket f of x. So we want to do the inside first, which in this case is f of x. Write a table of values for f of x, and f of x. We have 3, 5, -1, 4, and 1, 6. Then g of x, and g of x. If we put 3 into f of x for x, we get a 5. If we put 5 into g of x for x, what do we get out? Looking at our points in g of x, we have 6, 3, 2, -1, and -2, 1. There is no point with an x value of 5, so we would say it doesn't exist. So then g of f of 3 does not exist. Next one, if we plug in -1 to f of x, we get a 4 out. If we plug 4 into g of x, what do we get out? Our points are 6, 3, 2, -1, and -2, 1. We don't have an x value of 4, so again, if we plug in 4 to g of x, it doesn't exist. Last one, if we plug 1 into f of x, we get a 6. If we plug 6 into g of x, what do we get out? We do have a point here. We have 6, 3, so our output from g of x would be 3, which tells us that g of f of what was our original input, it was 1, and our final output was 3. So g of f of 1 equals 3. Note, the domain of g must include the range of f. So that's for this second one, g of f of x. We saw that because the domain of g of x, which was 6, 2, and -2, did not include the range of f of x, which was 5, 4, and 6, then some of our points for g of f of x did not exist. So this is for g of f of x. And then the domain of f must include the range of g. So here we have the domain of f was 3, -3, 1, and that is the range of g, -3, -1, and 1. So since the domain of f of x is the same as the range of g of x, then each of our points will have a value for f of g of x. Another way to say this is the domain of the outer function must include the range of the inner function. Evaluating a composition. To evaluate a composite function f of g of x at a specific value, substitute the value into the inner function, evaluate, then substitute this result into the outer function. The composition f of g of x has the following rules. Substitute the value of x in for x in g of x, then evaluate, then substitute the answer from 2 in for x in f of x. Example, if f of x equals x cubed minus 1 and g of x equals 2x plus 1, evaluate f of g of 2. So this tells us to sub 2 into the function g of x wherever there's an x. So we can write this as f of, what is g of x? It's 2x plus 1. and we're subbing in a 2 for x. So 2 times 2 plus 1. Then we can evaluate that, f of 4 plus 1, which is f of 5. And now this tells us to take the function f of x, which is x cubed minus 1, and sub in 5 for x. So we get 5 cubed minus 1, which is 125 minus 1, which gives us 124, which is our f of g of 2. G of f of 2, this tells us to take 2 and substitute it into the function f of x for x. So we get g of f of x is x cubed minus 1. We're subbing in 2 for x, so 2 cubed minus 1. We evaluate that. G of 2 cubed is 8 minus 1. G of 8 minus 1 is 7. And then we sub in 7 for x in g of x, which is 2x plus 1. So 2 times 7 plus 1, which is 14 plus 1, which is 15. And that is g of f of 2. And then f of 2, which we can write as f of 2. So take 2 and sub it into the function f of x, which is x cubed minus 1. So we get f of 2 cubed minus 1, which equals f of 2 cubed is 8 minus 1 is 7. And then we sub that value into f of x, which again is x cubed minus 1. So we get 7 cubed minus 1. 7 cubed is 343. Minus 1 is 342, which equals f of 2. Use the graphs of f and g below to evaluate the compositions. F of g of 6. So as we said before, we always start with the inner function. So let's look at the graph of g of x when x equals to 6. X equals to 6, go up to the graph of g of x. What is the y value at that point? It would be y equals to 3. So then this becomes f of 3 because g of 6 equals 3. Then we evaluate f of 3, so we look at our function f of x when x equals to 3, y equals 0, or f of x equals 0. So f of 3 is 0. F of g of negative 2, this means f of g at negative 2. So start with the inner function, g of negative 2. Go to negative 2 on the x-axis, go up to your g of x function, and determine the y value, which is 7. This gives us f of 7, because g of negative 2 is 7. And then evaluate f of 7 at x equals 7. Go up to your f of x function and determine your y value, which is 2. So f of 7 equals 2. G of f of 3, this time we're starting with the f of x function, and we're looking at when x equals to 3. So x equals to 3 on f of x, y equals to 0, which gives us g of 0 because f of 3 is 0. And then we evaluate g of 0. So look back on our graph. At x equals 0, what is the value of y for g of x? It would be 6. So g of 0 is 6. Then g of f of 7, starting with our function f of x, we look at when x equals 7 on the function f of x, what is the value of y? And it is 2. which gives us g of 2. Next, we look at g of x. When x equals 2, what does y equal? X equals 2, go to the function g of x. Our y value is 5. So g of 2 is 5. Last one, f of 9, which we can write as f bracket f of 9. Start by evaluating f of 9 on our graph. X equals 9, go up to f of x, go over to determine the y value, which is 3. So we have f of 3 because f of 9 equals 3. Then we want to evaluate f of 3, looking at our graph. When x equals 3, y equals 0, so f of 3 equals 0. Describing a composition. Consider the function h of x equals 5x minus 7. We can think of this function as being composed of two other functions. Function 1, multiply by 5. We can call this function f, so f of x would equal 5x. And then function 2, subtract 7. We can call this function g, so g of x would equal x minus 7. If h of x is a composition of f of x and g of x, which one is the inner function and which one is the outer function? Which statement is correct? Let's take a look at them. We have h of x equals f of g of x, which we can write as f bracket g of x. Then we substitute the formula for g of x into the brackets. G of x is x minus 7. And then we substitute what's in the brackets into f of x for x. F of x is 5x, so this would be 5 times x minus 7. And then we simplify by multiplying the 5 into the brackets, which would give us 5x minus 35, which is not h of x. So this is not equal to h of x. So we would assume that g of f of x would be the correct composition. Let's test it out. We can write this as g bracket f of x. Let's write the formula for f of x in the brackets, g of 5x. Then we plug 5x into g of x for x. So x minus 7 becomes 5x minus 7, which is what we're looking for. That is h of x. So this one is correct, which means the inner function is f of x, and the outer function is g of x. The function h of x equals x minus 6 to the power 4 is a composite function. Write two functions, an inner function g of x and an outer function f of x, such that h of x equals f of g of x. Well, if we think about it, h of x equals x minus 6 to the power 4. If we had this as just x, so one function is x to the power 4 and another function is x minus 6, then we have substituted x minus 6 into another function x to the power 4. So we can make our two functions f of x equals x to the power 4 and g of x equals x minus 6. And then we just have to decide on the order. So are we subbing in x to the power 4 into x minus 6? That would get us x to the power 4 minus 6, which is not the same as bracket x minus 6 to the power 4. But if we substitute g of x, x minus 6, into f of x, x to the power 4, then we would replace the x that is here with x minus 6, and then it would become x minus 6 to the power of 4. So our inner function would have to be the g of x, then f of g of x equals f of, what is g of x? It's x minus 6. And then we sub x minus 6 into f of x. F of x is x to the power 4. So now instead of x to the power 4, we have g of x, which is x minus 6 to the power of 4, which is our h of x. Determine two functions f of x and g of x where h of x equals f of g of x. A, h of x equals the square root of 3x minus 2. F of x is our outer function, g of x is our inner function. If we look at our function h of x, we have the square root of 3x minus 2. So if we made 3x minus 2 our inner function, g of x, and the square root of x our outer function, f of x, then f of g of x would equal h of x. So we have f of x equals the square root of x, and then g of x equals 3x minus 2. Then if we sub g of x into f of x, we would get the square root of 3x minus 2. Then f of g of x equals f of 3x minus 2, which equals f of x is the square root of x, and x is now g of x, which is 3x minus 2. So the square root of 3x minus 2, which equals h of x. H of x equals bracket x minus 4 squared plus 3 bracket x minus 4 plus 4. So we should notice that we have x minus 4 here and x minus 4 here. If we switch the x minus 4 to just x's, then we would have the quadratic x squared plus 3x plus 4. So our outer function could be f of x equals x squared plus 3x plus 4, and then our inner function is what was subbed in for x in the brackets, which was x minus 4, x minus 4. So our inner function would be x minus 4. Then f of g of x equals f of x minus 4. And that gives us f is x squared plus 3x plus 4. So everywhere there's an x, we're now going to sub in x minus 4. Then we get x minus 4 squared plus 3 times x minus 4 plus 4, which equals h of x. C, h of x equals x squared minus 6x plus 9. We could factor this. Doesn't really look like much here, but we can factor this to two numbers then multiply to 9 and add to negative 6 would be x minus 3, x minus 3, which is x minus 3 squared. So if our outer function is x squared and our inner function is x minus 3, f of x equals x squared, g of x equals x minus 3. Then f of g of x equals f of, what is g of x? It's x minus 3. And then f of x is x squared, but we're replacing x with x minus 3. So we have x minus 3 squared, which equals h of x. Given that h of x equals f of g of x, determine g of x. H of x equals the square root of 9 minus x, and f of x equals the square root of x. h of x equals f of g of x, which equals f of x is the square root, and then g of x inside f of x. So square root of g of x, and h of x is the square root of 9 minus x, so that is the square root of 9 minus x, which means that g of x would have to equal 9 minus x, because we replaced g of x here with 9 minus x to get h of x. H of x equals 12 over 7x minus 2 squared, and f of x equals 12 over x squared. So what are we subbing in to f of x to end up with h of x? Well, we're replacing this x value with 7x minus 2. So that means g has to be 7x minus 2. If we look at h of x equals f of g of x, which equals 12 over g of x squared, so that's f of x with g of x in place of x, which then equals 12 over 7x minus 2 squared, which is our h of x. Then g of x equals 7x minus 2. The cost C of manufacturing X engines is given by the function C equals 75x plus 900. The number of engines produced in T hours is given by xt equals 10.5t. Determine C of x of t, which equals C of, what is x of t? It is 10.5t, so C of 10.5t. Plug 10.5t into the function C wherever there is an x, and we get 75 times 10.5t plus 900, and then we can multiply the first term. (75) times 10.5 gives us 787.5. So C of x of t equals 787.5t plus 900. What does C of x of t represent? Well, C is the cost of manufacturing X number of engines, and then X of t is the number of engines produced in T hours. So C of x of t, our output is C, it's the cost, and our original input is t, because we're inputting t number of hours into xt first and calculating that, and then we're putting that value into the cost function and calculating the cost. So C of x of t represents the cost of manufacturing engines for T hours. Determine the cost incurred after 8 hours of production. C of x of 8 in this case, 8 hours, equals 787.5 times 8 plus 900. 787.5 times 8 is 6,300 plus 900, which equals 7,200. So the cost for 8 hours of production is 7,200. Determine the time that must elapse for the cost to be 33,975. The cost based on the time elapsed, that's C of X of T. And we are trying to find the T value. So our function, C of X of T equals 787.5 T plus 900. We know the C value, 33,975 equals 787.5 times T plus 900. We subtract 900 from both sides. We get 33,075 equals 787.5 T. Then we divide both sides by 787.5. $33,075 divided by 787.5 gives us 42. So we get T equals 42. 42 hours of production results in a cost of 33,975. That brings us to the end of the Chapter 10 notes.